Hey everyone, I wanted to review the math in this YouTube video because I didn't realize until quite late last Thursday evening that we were all having difficulty with the math. So I wanted to just go through the equations and identify the computations and how to get to the answers for. So we'll start with the DC questions and then move on to the AC. So in the DC questions, we were asked for the voltage at VA, point VA, which was right here. We were asked for total current, IT, current of Q1, voltage of the collector of Q1, and voltage of the collector of Q2. So let's take a look at VA. Before we can do VA, we have to identify IT, so total current. So the differential amp Q1 and Q2, half the current is traveling through Q1, the other half of the current is traveling through Q2, and they merge right here at VA, and I believe this was RT and this was RC. So RT actually contains the current of both stages, Q1 and Q2. So we should be able to find IT through the current calculator for RT. So let's take a look at that. And let's go ahead and calculate IT. So IT is going to be equal to the voltage of our base, which was 0 volts, minus the 7/10 drop across the base to emitter, and that's going to be subtracted from our negative VEE, and all of that is over RT plus RE1 and RE2 parallel, because remember, it's shared between Q1 and Q2. So RE1 parallel to RE2. So let's go ahead and get some numbers in that. So we know that VB is 0. And VB is not truly going to be 0, but it's close enough for what we're trying to calculate here. Because again, we have a transistor as a current amplifier. We've got a little bit of current between the base and the emitter, which produces a large amount of current between the collector and the emitter based on the beta DC of the transistor. But for tonight's calculations, let's just go for 0, minus the 0.7 volt drop, minus the negative 15 volts, VEE. That's going to be over our RT. And I went ahead and changed RT and RC to 12K. Didn't want to just do the calculations for you and you guys write them down. So this is how we're going to work through it. So RT is 12K plus RE1 parallel to RE2. And you know, this is actually the spare case, or the unique case, where we can do R divided by 2, because RE1 and RE2 are the same. So this is that unique case where we have RT is equal to RT divided by the number of resistors, only because they're the same, and because we have 2 resistors, we just divide by 2. So we have 200 ohm resistors. That's going to be 50 ohms. So I'll just put the 50 right there. Okay. So we have a negative 0.7 minus a negative 15. It's going to be 14.3, and 12K is going to be 12050. Let me grab my calculator and we'll punch a number out for that because we need that number. So 12050 divided by try that again. 14.3 divided by 12.0.50. I have a total current calculated in this as 1.18. I'm going to go ahead and round right here 7 milliamps. Okay, now remember that current is divided. Half the current's traveling through Q1, the other half the current's traveling through Q2. So the current for Q1 is going to be half of that. So IT, I have 1.187. And if we were to round that to 3 significant digits, that would be 1.19. So we'll take that number, 1.187, divided by 2. We're going to get 593 microamps. Okay, so this is 593 micro, and this is milliamps. Woohoo! Now we can get some numbers out of this. Okay, so sorry about the size of the easel. This is my granddaughter's. I had to go in and borrow it. VCQ1, that was a freebie. So here's Q1, voltage at the collector. Of course, the collector is tied to plus 15. I would call that 15 volts, right? There's a collector, there's plus 15. Those two are tied together. No resistor, 15 volts. Okay, voltage of collector Q2. Okay, here we're going to have to do a little bit of calculation. We know what the total current is. We know what the current is through Q1. We know what the current is through Q2. If we know what the current is through Q2, well, we can definitely find the voltage drop across this RC. If we know what the voltage drop across the RC is, we can find the voltage at Q2. So let's go ahead and take a look at that. Let's do, so we're just use Ohm's law. V over IR. We know what R is. We know what I is. We're going to find the voltage. Okay. So voltage of RC is going to be equal to IEQ2, which is the same as IEQ1, times the 12K, so RC. Okay, I'll bring this down. 593 micro times the 12K. That number times 12K. I come out with 7.12 volts. Okay, now that's the drop across this resistor, not the voltage of RC, just the drop across the 12K resistor. So what we do now is we're going to take this equation, we're going to modify it a little bit, and we're going to say, I'm going to move this down here, okay, VC of Q2 is equal to VCC minus IEQ2 times RC. Okay, VCC is 15 volts. Okay, IEQ2 times RC is 7.15. 7.12, and that number is voila, 7.88 volts. Woohoo! coming back, VA, we need to answer that. We know what the total current is. We know what this RT value is. Now we can find the voltage at VA. Okay. Erase all of that. I'm going to do a little bit of cheating because I know that this is the 12K and I know that this is the 12K. Well, no, I can't do that because half the current's traveling through here. All the current is traveling through here. So, okay. Let's find the voltage of RT. And of course, Ohm's law, V over IR. We know what the total current is. So, I times IT times RT is going to come out to 1.187 milli times the 12K. And the number I have, that one, times 12K. I came out with 14.24 volts. Okay, 14.24 volts. We know this is a negative number. We know the drop across this 12K is 14.24. Okay, so if we do same equation as earlier, VA is going to be equal to VEE. And because this is going to be a negative value, let's go ahead and add this 14 because, again, this is being, our base is 0 volts. This 0.7 volt drop is going to be in a negative going direction because this is minus 15 volts. So that's going to be negative 0.7 volts. This is going to be even less than that. Okay, so we'll do VEE minus, or add VRT. That should come out right. So minus 15 volts plus the 14.24 should come out to 18176. Make sure I'm right on that one. No, I'm wrong. Too late at night here. 5, 9 volts. Negative going. Okay, so I came out with a negative 0.759. Just about 0.8 volts. Again, yours will probably be a little bit less because you have a 10K there in lieu of the 12K. Awesome. All right, let's get some AC values out of this thing. So I'm gonna get all of this out of here.